Hello, pre-calc students. This is Unit 8, Day 5. Today we're going to be talking about powers of complex numbers. And just as a quick recap of what we know already in terms of operations of complex numbers, when we have numbers in polar form and we're trying to multiply them, so as a quick recap, if I were to have R1 cis theta 1 times R2 cis theta 2, that we know the rule for the product is, based on yesterday's notes, you multiply the R values, R1 times R2, and then you would add the angles theta 1 plus theta 2. So that's a good rule that we have if we're multiplying two numbers in polar form. Similarly, if we have the rule for division, if I had R1 cis theta 1 divided by another polar number, R2 cis theta 2, the resulting quotient would be R1 divided by R2, and the angles theta 1 and theta 2 would get subtracted. So we have this result for the product, and we have this result for the quotients based on day 4. So now what we can do is we can move on to think about, if we know those two rules, how can we apply that to raising complex numbers to a power? So for example, if I wanted to compute 2 plus 2i radical 3 raised to the 4th power. Using traditional techniques of multiplying this by itself 4 times would take a really long time. It's not impossible, but there are easier ways to accomplish this if we think about converting into our polar form, and that will eventually help us develop a rule for raising polar numbers to a power, instead of having to do what I said, which was multiply this by itself 4 times. Let's start talking about just 2 plus 2i radical 3, that inside piece. So if I were to convert that 2 plus 2i radical 3, it goes to the right 2 and then up 2 radical 3. So the hypotenuse of that triangle would be 4 with a reference angle of 60. So therefore, 2 plus 2i radical 3 is the same as 4 cis 60. So then let's kind of move on from here and talk about, if this is 4 cis 60, how can I then square this number? So if I wanted to take, before I get to the 4th power, let's start smaller. If I said to square that, that would be the same thing as doing 4 cis 60 squared, because this is the converted form. Well, because we don't know how to raise this to a power yet, what we can do alternatively is say, what if I were to multiply this just by itself? Do 4 cis 60 times another 4 cis 60. We know the rule for multiplication because we just wrote that up above. The rule for the multiplication is if you multiply the R values, you would get 16. And then if you add the angles, 60 and 60 add up to 120. And from there, we can kind of keep building our pattern out. So eventually we want to get to the 4th, but let's take a pit stop for a second at the 3rd power. So if I try and do this cubed, which again is the same thing as 4 cis 60 cubed, the way we can break apart this is, what if I did 4 cis 60 squared, which by the way is this, times another one of those 4 cis 60s. So again, take your answer from the last step, which is 16 cis 120. That's what it would have been squared. Multiply by one more 4 cis 60, and then that will give you the answer that we're looking for. So this is going to come out to be, in the end, 16 times 4, which is 64, cis 120 plus 60, which is 180. Okay, last but not least, if we eventually build this out to the 4th power here, let's see what the result of that would be. So we're going to get 2 plus 2i radical 3 to the 4th would be the same as 4 cis 60 to the 4th, which is taking the last answer, which is when it was cubed, and multiplying it by one more 4 cis 60. So if I multiply by one more of these, 64 times 4 is kind of a large number, but it's 256 cis, and then 180 plus 60 is a total of 240. Okay. So what I want us to start looking at is the connection between the number in polar form to a power and the final result. So let's kind of like draw some connections here. 4 cis 60 squared is the same as 16 cis 120. 4 cis 60 cubed is the same as 64 cis 180. And finally, 4 cis 60 to the fourth is the same as 256 cis 240. So the question is, what happens to the R value, and then what happens to the angle? And with enough practice, if I kept building the pattern further and further and further, what I'm hoping you would recognize is if you do R cis theta and raise it to a power, I'm going to call that in general n, then the rule is the following. The R value gets raised to that power. You can check it on your calc. 4 cubed is 64. 4 to the fourth is in fact 256. So R is going to get raised to the n. Now on the inside, what happens to the angle? Well, if you look at 60 and 4, the relationship here is that these two numbers get multiplied. 60 times 3 is 180. 60 times 4 is 240. So theta is going to get multiplied by n. And I give myself a little bit of space here just because I'm going to tell you the name of this theorem. There's a famous French mathematician who came up with this theorem. His name is De Moivre, spelled like this. So De Moivre's theorem states that if you take a polar number and raise it to a power, you would raise the R value to the power, and then finally theta would get multiplied by the power n. So if we're good with that concept, let's just apply it to a few different scenarios. I have some practice questions with this whole new power rule here. So at the top of my next page, I'm just going to write down the rule so we have it to reference, that R cis theta to the n is R to the n cis theta times n, like that. So let's do the following evaluate problems. Number one, let's take radical 2 cis 150, and then we'll raise that to the fourth. According to De Moivre's theorem, De Moivre says if you take the R value, radical 2, and raise that to the fourth, and the angle of 150 and multiply that by 4, then that would be the correct evaluation using this new rule. So let's try and simplify this a little bit further. I know radical 2 squared is 2. If I do that again, I would get another 2. So radical 2 to the fourth is 4. The number out front is 4. Cis, and then 150 times 4 is 600 degrees. When you start seeing problems with De Moivre's theorem, you're going to start seeing in many cases that this angle starts to get pretty large. Not a big deal, because if the angle is large, all that means is that I'm rotating around my axes more than once. So if you think about one complete revolution as being 360 degrees, you can actually subtract 360 out of this to figure out where the new angle is going to end. And you can do that as many times as you need to figure out where this angle actually terminates or ends. If I subtract 360, that becomes a 240. So it rotated around once 360, and then beyond that, it goes another 240 degrees, which we know winds up being in quadrant 3. So here's where the angle 600 degrees would end after rotating around once, and then another 240 beyond that. So create that right triangle like we always do with the x-axis. The reference angle here would be 60 because the angle 240 has that reference, and then 4 goes on the hypotenuse. So to complete the picture, across from 30 up here would be 2, across from 60 then is 2 radical 3. They both need negatives. So this polar number to the fourth power, even though I was able to successfully keep this in polar form, in rectangular a plus bi form is -2 minus 2i radical 3. So we just have to read directions for our questions. Sometimes it will say leave your answer in polar form, then I would have stopped here. But if it says put it back into rectangular or that a plus bi form, we got to go that extra step then. All right, moving on. Let's do one that has some radians in it, because we love radians. So we got 3 cis pi over 6 to the 5th power. 3 cis pi over 6 to the 5th. Okay, let's use De Moivre's rule. Even though this is radians, it would still apply. So it's going to be 3 to the 5th cis, and then the 5 is going to get multiplied by the pi over 6 on the inside. So what seems potentially maybe a little bit scary at first, 5 times pi over 6 on the inside, that's just the angle 5 pi over 6. And we can convert that to degrees if needed, but I'm going to leave it in radians, and we'll sketch that in a moment. 3 to the 5th, by the way, is 243. That you would just get from your calculator. So if I were to convert this now back to a plus bi form, that rectangular form, 5 pi over 6, hopefully we've done enough radian sketching that you're feeling pretty confident with it by now. 0's here. Halfway is pi, or 6 pi over 6. So 3 pi over 6 is a quarter revolution. 5 pi over 6 is definitely in quadrant 2. With a reference of pi over 6, or 30 degrees, is the reference angle. And then 243 is what goes on the hypotenuse, kind of a large number there. But we know the pattern from here that across from 30 is half of that 243. Well, half of 243 is a decimal, but I'm just going to leave it as the fraction 243 over 2. Now, it's kind of a weird number, but we'll just go with it. And then across from 60 is 243 over 2 radical 3. And it's going left, so we need a negative. So when all said and done, this converts to left 240, yep, that's right, 243 over 2 radical 3, plus the 243 halves I. Final answer in a plus bi form. So we've seen 2 examples now of how de Moivre's theorem can be very quickly applied. That new rule takes us 1 step, but then the rest of the work is just in the converting, which we've done a lot of converting up until this point. So hopefully you're feeling pretty confident with that strategy. Last thing we're going to do is, what if I don't start with a number in polar form? What if I gave you a number in rectangular form and I want to raise that to the 8th? The reason why polar form is so useful for us is because I can do this power rule so much faster in polar form than I can in rectangular. Radical 3 plus I, that binomial to the 8th, would have to get multiplied by itself 8 times if I really wanted to figure out what this is expanded to. But because we have our shortcut now, let's actually convert radical 3 plus I to polar form first. So that quick conversion is to the right radical 3 and up 1. So if I complete the picture here, hypotenuse is 2 and the reference angle is 30. Radical 3 plus I is 2 cis 30 to the 8th. Raising this to the 8th is so much faster than trying to figure out what that is to the 8th, because we just do 2 to the 8th, and then 30 gets multiplied by 8. So 2 to the 8th is 256. Again, if you didn't know that, play the game 2048 on your calculator, or not your calculator, how about your phone maybe? And that will help you remember powers of 2 more easily, or type it into the calc, that's fine too. 30 times 8 is 240 there. So you've got this all set up, 256 cis 240. Last step, we'll convert it back to a plus bi form. So 240 is in quadrant 3. And the reference angle, if it's 240, is 60 degrees. 256 goes on the hypotenuse. Last step is then filling in the other missing sides. Across from 30 would be half of 256, which happens to be 128. So therefore, across from 60 is 128 radical 3. And finally, they just both need negatives because we're going left and we're going down. Final answer is negative 128 minus 128 I radical 3. And that's it with power rule. So next time in class, of course, we'll do some more practice with this. If you have any questions, let me know when we get started next time. Have a great rest of your day.